Okay, so we have another question says that the helicopter has a maneuver that makes a horizontal turn with a radius of curvature of 400 meters. Okay, that's the radius of the curvature. And this one means that very long. And then determine the very long, and therefore it is long, and then we show in the short form, that's what it means. They determine the lift force FL required and the angle of the bank theta when it is flying horizontally with a speed of 40 meters per second. Show that the theta increases if v increases, and by also calculating the theta when v is 60 meters per second. So what it means is that find theta when v is 40 meters per second, and then find theta, let's say theta 1 and then theta 2, v is 60 meters per second, and then it means that compare theta 1 to theta 2. Okay, this is the question says. Okay, now let's show the forces acting on the helicopter. So we have this one, yeah, that is the MAN. Okay, let's put the as a, so this one is the N, and then we have the B. Okay, and then we have the weight of the helicopter. So weight of the helicopter, and then tangential acceleration is 0 because it says that the since, then let me add it here, v is constant. Okay, so let's write the force balance, and then it will be that the forces acting in N will be that MA into N. Okay, and then we have a force which is the lift force FL, and then it has two components if we see it as a theta. So FL N and then FLB. FLN will be FL sine theta, and then FLB will be FL cosine theta. Okay, so it means that, so we will have FL N will be FL sine theta, which is positive, that will be equal to MA into N. Okay. And then we will have the force balance for the B direction. F and B is equal to 0, and then we don't have any acceleration, so no AB. Okay, so it means that FL cosine theta will be equal to the, sorry, let me just write fully form, minus the W will be equal to 0. That's the second equation. And then we can write this one in the next slide. So FL sine theta will be equal to MAN is that V squared by rho, and then FL cosine theta will be equal to the M into G. Okay, so that is similar to the Bankit turn problem. Okay, and then if we divide, so it will be that the tan theta will be equal to V squared by into rho G. Okay, so the question says that the find theta when V is 40 and then V is 60. So then tan theta will be equal to then 40 squared by 400 times 9.81, and then tan theta will be 60 squared by 400 times 9.81, theta tan 1, and then tan theta 2. Okay, then we have the tan theta 1 will be equal to 1600ths for the first one, divided by 400ths, and then that one divided by 1.81, which makes us 0.41. And for the second one, it will be that 3600, 400, 9.81, and then tan theta 2 will be equal to 0.92. Okay, from here we can find that the theta 1 is equal to, let's find the theta 1. So we have the, let's see, do we have, so we don't have the, so let me use Excel for this one, and then, so let me use Excel for finding this one. Okay, so we have, so I mean arctan of 0.1 is 41 actually. So we have the arctan of 0.92. So first one makes, okay, so I need to convert this one to angle, yes? So that will be degrees of this one, that will be degrees of this one. The first one makes 22 degrees, second one makes 43 degrees. Okay, let's see what does the question say. So if v increases, theta increases or not. So you can see that if we increase the v from 40 to 60, theta increases from 22 to 43. That works.